So let's start with the previous definition. Okay, we have the definition f prime of a equals the limit as x approaches a, f of x minus f of a divided by x minus a. Okay. And this is a good definition. It's valid, but at times it will be more convenient to use a slightly modified definition. And how we're going to modify it? We're going to say that we're going to let the quantity x minus a to equal h, right? So x by itself is now a plus h. That's what I was talking about. We're going to move x so close to a that we're going to say the difference is h. And now we're going to say that as x approaches a, right?
H is the difference.
H is the difference.
A and then A plus H is the difference.
H is the difference between the moving value of x and the fixed value of a. Go ahead. Or maybe just let me finish the statement here. Okay? As x approaches a, we're going to say that h approaches 0. Okay? Go ahead.
H could be compared to delta in the precise definition, correct?
That is very correct. Yeah.
We've seen it referred to as delta.
I'm sorry?
So I think I've seen it in other examples referred to as delta
Yes.
notation.
Yes. Okay, so let me turn it to the next page, and let's see, using this modification, how the definition going to look like. Okay, so if we're going to replace x with a plus h and x minus a with a, then we have the following definition. F prime of a is now the limit. Again, instead of x approaching a, we're going to say that h approaching 0. Okay? And then, instead of f of x is a plus h. So it will be f of a plus h minus f of a. That doesn't change. And instead of x minus a in the denominator, we have simply h. Okay, so this is basically the new definition or the modified definition of the limit, including h. It's also useful when you calculate, as you saw in the lab, if instead of looking at the difference between x minus a in your calculation, if you set it up like so, you can now let h be any value that you want to, as close to 0 as you want to, and then you get a very good estimate of the slope of the tangent or the derivative. Go ahead.
Can you move the last over just for a second?
The last part? Not a problem. Okay. And you recall we used this definition, even though at that time at the lab I didn't tell you this is the definition of the derivative. We used this definition in both assignment 1 and assignment 2 in the last part, and asked you to calculate the limit of this expression. And you're going to see in the next example something that I asked you actually in the lab. So this is something, since the lab is still open, you can use that to verify your lab result. All right? So that would be the next example.